right, welcome. Mr. Norton here. Lesson 5, practice answers. So, I've been looking at all that, and that's how we do, right? I see Miss Keogh in lesson 4. That's what she did. So, reduce. Can we reduce that? No. Are there any holes? So, if we can't reduce it, there are no holes. So, let's go. Holes does not exist. Then let's go vertical. Vertical, you set your denominator equal to 0 and solve. So there's 1 at 2, and here it is right here. I have the graphs all done for these just so I don't have to waste any time. There's our vertical asymptote. All right, I know it's a funny word, but okay. Horizontal, right? So if the powers are the same, so that there's no power in the top, 1 in the bottom, they're not the same. If the higher degree is in the denominator, right, which it is, so then it's just y equals 0, which is right. Oop, I must have moved my page up a little bit. Hold on. There we go. Sorry about that. All right. And then we do slants, right? The slants you do is if the numerator is bigger than the denominator, which is not the case, so it does not exist. So then looking at this, there is no x-intercept, so y-intercept is at 0, 2. And you can always plug x in for 0 or y in for 0 to see what your x and y axes is. All right, so let's move on. Number 2. Again, I have it all copied. I did it already. So reduce, can't reduce the fraction. Are there any holes? Since we can't reduce the fraction and cancel anything, there are no holes. Vertical asymptotes. Ooh, sorry. Touchscreen. Vertical, take the bottom. Set it equals 0, I get x is 2 again. Here it is, right there, vertical asymptote. All right. Then I look horizontal. All right. If they are the same, right? They're both to the first power. So it's just y equals a over b. So 1 over 1. So y equals 1. So then at, why do I have it at 2? Hold on. Oh, duh. It's right here. Horizontal. Y equals. Okay. Slant is when the numerator, top, is bigger than the bottom. Not going to happen. Does not exist. Ooh, we do have an x and a y-intercept. So we have what? I would have to plug it into my calculator again. So we would have 0, some number, and some number 0. I don't have it in my calculator right now, so but that's what we'll do. All right, let's go on to 3. 3. There we go. There's our graph. So again, can we factor it? No. So there are no holes. I'll try and do this one a little bit nicer. Does not exist. Vertical, take the denominator. Set it equal to 0. So there's 1 at -3. Bang, right there. Horizontal. All right. So we have, it's 1 over 1. Or sorry, if we were to FOIL this out, we're going to have an x squared, and the top is an x. So if the bottom, the denominator is bigger than the top, then it is y equals 0. Which I have to look into because this graph actually comes higher than that. So I will get back to you. I'll have to look into that one because it just didn't make sense to me. Okay. And then slant is when the numerator is bigger than the bottom. Doesn't happen. So then our only intersection, x and y intercepts, is at 0, 0, right there. Okay. All right, so next one, factor top, factor bottom, cancel. Can't do that. So there are no holes. Does not exist. Vert, we take the bottom. 6x minus 4 equals 0. 6x is 4. X equals 4, 6, or 2/3. All right. Hold on, my graph does not fit what I had. All right, so I'll just redo this graph in a second. So this one. All right, so there is my x equals, come on, move over a little bit. All right, well, let's just keep going. Horizontal, right? Top is big, so does not exist. All right, so this one's gonna have a slant height. Since the top is bigger than the bottom, I'm gonna go 2x squared plus 0x plus 5 by 6x minus 4. So then I'm going to go, all right, so what times 6 gets me 2? So 1/3, and then I need to get x squared x. So I do that, so I get 2x squared minus 4, minus 4/3 x. And you change the signs, they're gone. It doesn't even matter because you don't care about your remainder. So, and then you just go y equals that. So there is a line. Don't worry about these pink lines. I can't get rid of them right now. That's going to go like that. That is your slant height. So I'm just going to kind of draw it. I don't know why I can't move this. Oh, maybe now I can. Okay, there we go. Let's get rid of that. So that one's at 2/3. There's your slant height. And then the graph itself is actually going to look something like, let me see, 2 here, here. So it's going to look something like that. And again, I just graphed it. And the other one is going to look something like, where is it? Something like that. All right. And this last one. So there's our graph. This one does have a hole. Here you go. Here's how you get your hole. Oh, let me just shrink that line. We factor the top, x plus 4, x minus 2 over x minus 2. Oh, look at that. They cancel. Hole. If they cancel, that's a hole. I have a hole at x is 2. So wherever x is at that graph, right, it's somewhere along this line, bang, right there, there's a hole in our graph. Then we just keep going on with the same thing. Vert, we take x minus 2 equals 0. So there's a vertical asymptote, again, right there, where our hole is. Because when you usually get a hole when your graph goes through your hole. Or sorry, crosses your asymptote. Let me rephrase that. Horizontal, right? There does not exist because, slant, there is a slant because the top degree, which is your highest exponent, is larger than the bottom. So we got a synthetic divide. So I'm going to, what times x is x squared? So x, then, right, you really distribute to both of them, minus 2. You change the signs, add 4x minus 8. What times x is that? 4x, so plus 4. Change the sign, 0. So this quotient is actually your slant 4. Perfect. All right, that's it. Thank you. I'll see you guys on Friday.